That was great. All right, a big welcome to Eleanor watching in Quebec, to Catherine and Joshua in Texas, to Elliot and Rosie from Michigan, to Ibrahim in Canada, who said that he's been studying and you're going down, Math Dad.
Ooh.
And to Annabella in Alaska. I see Science Mom Amber, Isaac, Olivia, Rebecca, you. Welcome, everybody. And a special welcome to you if you're watching the replay.
I'm surprised anyone even dared show up today. No.
I am Team Unbeatable Science Kids, and I am confident that you guys have practiced, you've looked through the notes, you're going to get every question right.
I don't know about that. I wrote some harder questions this time, Science Mom.
We did put in a few harder questions. If the majority of the students get all the questions right, we're going to play every funny dance video that Math Dad did, plus a new one. If Math Dad is able to stump you guys, then at the end, Math Dad will do some powerful
I'll just flex for 30 seconds and you guys will just have to watch.
So go to itempool.com/sciencemom/live and get ready to test your knowledge and see what you have learned about our atmosphere, the lithosphere, and the hydrosphere, because this is a comprehensive quiz. Any material we've covered is fair game.
All right. I'm going to start off with a question involving some numbers here. In the atmosphere, how many times more oxygen is there than carbon dioxide?
Ooh, so there's a little bit of math in this question.
So is there about 3 times more, about 60 times more, about 500 times more, about 1,000,000 times more? So which is it? We know there is more oxygen than carbon dioxide.
There is.
But how much more?
But how much more?
Question about the relative sizes here. And
so
I'm sure we have not framed this exactly this way in the class so far. So this is a genuinely difficult question.
This is a great one, because you should know just off the top of your head after taking this class, you should be able to say this % oxygen, this % carbon dioxide. But then once you have those two numbers, can you tell how much bigger one is than the other?
Look at that, Science Mom. It's close. I don't know which
there
one's actually.
There are two answers that are close.
All of them are getting some votes.
But Math Dad, these, it's unbeatable science kids. They've studied. They know what's going on.
Did you hear that? I think it was the sound of hopes and dreams shattering.
No.
That's what I heard. All right. Let us reveal the answer.
Oh, yes.
Oh no, they got it.
They got it right. Carbon dioxide is just 0.04% of our atmosphere. Oxygen is 21%. That means that there is about 500 times more oxygen in the atmosphere than carbon dioxide. That's a big difference.
Yeah, kind of crazy. And when we surveyed people on the street and asked them about that, said, what's in the atmosphere? There's a lot of carbon dioxide, a lot of oxygen. But no, carbon dioxide, barely a trace of it. It's
really small.
It's measurable, but boy, not so much. But that makes it really powerful when the levels change.
Yes, when the levels change, it makes a big impact because there's already just a small amount.
All right, they got lucky on the first one. All right, the largest tectonic plate on Earth is which plate? The Eurasian plate, Antarctic plate, North American plate, or the Pacific plate? So they were supposed to miss the first one, and then this one was a little easier. But
this one is a little bit easier, and hopefully they remember from when we talked about tectonic plates, because there's one that is quite a bit bigger than the rest, although all of these are enormous.
Well, massive.
All right, I think we have a clear winner. Let's go ahead and finish and reveal. No worries if you haven't had a chance to vote yet.
All right. Pacific
plate is correct. The Pacific plate is bigger by a lot.
And anytime there's a question, what is biggest, and then there's a Pacific is the answer. Pacific is just massive ocean, and the plate covers that whole ocean.
Yes, and around the Pacific plate is the
Ring of Fire.
Ring of Fire. Most volcanoes occur in that area.
Oh, okay, so this is a multi-select problem. Which of these rocks are igneous rocks? So only select the ones that are igneous rocks. We've got granite, shale, limestone, basalt, pumice, and gneiss.
That's a nice rock.
Nice.
Gneiss is one of my favorite rocks just because of the name, you guys. It's kind of a fun name.
Kind of nice.
I'm getting all covered up by the bars here.
Yeah, they're kind of pokey, but when you're as tough as I am, you can withstand the pain of the bars hitting.
Now, how are we going to call this one a victory? I say
if any wrong answer beats out any right answer, then clearly I've stumped them.
Okay, so yeah, don't be just going and selecting all of them. Make sure you only select ones that are igneous, because if we just get straight bars all the way down, then Math Dad's going to claim victory.
Maybe they're all igneous. Maybe they should select them all, Science Mom.
Oh, no hints from me. Math Dad told me I need to be really careful not to give hints.
All right, revealing the answer. And we've got granite, basalt, and pumice.
Ooh, so those ones did have the most votes, but boy, a lot of people did pick shale, limestone, and gneiss as well. Shale and limestone are sedimentary rocks. Gneiss is a metamorphic rock.
So yeah, just be careful on those, but you did get it right. The correct answers had more votes than the incorrect answers.
So good job, unbeatable science kids.
Nicely done. Ooh, on a timeline, which is closer to the Tyrannosaurus rex? A stegosaurus, a cell phone, a trilobite, a pedurps, or arthropleura?
So I have to show a little picture here. We did talk about each of these animals in class, but just in case you don't remember, pedurpes is one of the early amphibians, enormous. Like if you were on the ground laying down and pedurpes came up and laid down next to you, it would be as long as you. Same with arthropleura, one of the biggest invertebrates ever. And then we have, of course, trilobites and stegosaurus and cell phones. And some of you watching may not know that cell phones used to have buttons. Mine
and an antenna.
Yeah, they used to have numeral buttons on them and look different than they look now. Now they look more like miniature computers. But which of these existed closest in time to the Tyrannosaurus rex? Because one of them is quite a bit closer than the others.
Okay.
We have a clear winner. Let's go ahead.
The votes are in, and the answer is cell phones.
Yes, the answer is
They got it wrong,
cell
Science
phones.
Mom.
Oh no.
They said stegosaurus.
I thought that okay, let's show the graph here. This one was probably one of the trickiest ones we have. So stegosaurus is closer to Tyrannosaurus rex than any of the other animals. So when we talked about trilobites and pedurpes and arthropleura, those are millions and millions of years further away. But stegosaurus went extinct between 80 and 90 million years before Tyrannosaurus rex. Tyrannosaurus only went extinct about 67 million years before cell phones, before the modern era. So isn't that amazing that we are closer in time to a Tyrannosaurus rex than...
It's mind-boggling to think that, but yeah. So stegosaurus was one of the earlier big dinosaurs. Yeah. All right, and so it begins, Science Mom.
So I have to say, there's some talk in the chat about the science kids being avenged.
Oh.
Do you think they'll make a comeback, Math Dad?
I think there are going to be a lot of tears today, and I'm not even sorry. All right.
You guys need to put him in his place, okay? Every single question from now on, we're going to crush him.
All right, which of the following are minerals? We've got ice, ruby, opal, coal, quartz, and salt. And remind me, so what were the requirements to be a mineral, Science Mom?
So to be a mineral, you have to have a defined crystal structure and a chemical formula. So if you have some sort of organized crystal structure, but there's no chemical formula, like it's just a mess in there with lots of different materials, that's not a mineral. And if you have, I'm totally getting covered up. And if you have a chemical formula, but you don't form a crystal, you're not a mineral. You have to have both chemical formula and a crystal. So
everything got some votes here. Let's see if they selected the correct choices.
Yes, they did. Ice,
totally did.
Ruby, quartz, and salt are all minerals, and opal and coal are not minerals. So they are mineraloids.
So what do they fail on? They don't have a crystal structure?
They don't have a crystal structure. So coal is actually a little, it's a little weird with what compounds make it up. There's not just one chemical formula for coal. But opal and coal both, they don't form a crystal structure. So they're a mineraloid substance.
Gotcha. All right, nicely done, guys. Up next, select the false statement. So which statement is false? And I've got 5 different statements about planets here. Mercury is the smallest planet. Neptune is mostly made of water, methane, and ammonia. The atmosphere of Mars is mostly carbon dioxide. Human spacecraft have visited every planet except Mercury. And the volume of Jupiter is bigger than the other 7 planets combined.
Now, all of those are true statements except for one. One of those is false. And Math Dad, this is another one that is a little bit tricky. I think if they get this one right, then I think that should like balance out the one about the cell phone and the Tyrannosaurus, because that was another tricky one. Because I know that some of our undefeatable science kids are like, they really want to see all the dances. They don't want to watch you flexing for 30 seconds at the end. What do you think? Could we
don't get their hopes up, Science Mom. You're just going to crush their dreams. Oh. All right. Well, one of the statements here got a lot of votes.
It did. Let's
see. Is it the correct one or the false statement?
It is the false statement. Oh. So we have sent spacecraft to every single one of the planets, which is pretty remarkable. And Mercury is one of the more difficult planets to visit just because the conditions there are so extreme. You have, if you're on the dark side, it's incredibly cold. And if you're on the hot side, it is incredibly hot. But we sent a spacecraft to Mercury and it orbited around and around and around until eventually its orbit decayed and it actually crashed into the planet. So it didn't really land because it got destroyed on the impact. But there is a human-built machine on the remnants of it, broken pieces of it, on Mercury. And all the other statements were true.
That's right. All right. Most liquid fresh water on Earth is located in the oceans, underground, in lakes and rivers, or in clouds. Which will it be?
And then Isaac's saying the dark side of the forest. No, like the side of Mercury that's experiencing night. That was what I was referring to. Oh. And make sure you read this one carefully.
Math Dad, this is what we call a whopping. Ooh. Ooh.
Make sure you read this one carefully. Most liquid freshwater is located where? In the oceans, underground, lakes and rivers, and clouds are your options. All right, let's go ahead and finish and reveal.
And they crash and burn. Oh, they got it.
They crushed it. They crushed it. Underground is correct. Almost 30% of fresh water, and that includes frozen fresh water. So 30% of fresh water total is underground. And then if you take out frozen and you're saying liquid fresh water, then the percentage is way higher. So groundwater is super important.
All right. They got lucky on that one too. You know, people get lucky sometimes. Yeah, it happens. All right, which of the following statements is true? You can always see a tornado before it arrives. Tornadoes have been recorded in every U.S. state. Low wind shear is necessary for tornadoes to form. And tornadoes cannot cross water. So select the true statement among those.
This is kind of the opposite of what we did before. All of these are false except for one. One of these is true. Do you remember our lesson on tornadoes when we talked about tornadoes? And can you remember, or do you remember enough from it to recognize the trick here? Which one is true? Which one and which ones are false?
Well, select the one that's true.
Yep.
I got to say, I didn't know a ton about tornadoes before that lesson. So I learned a lot that day.
And we do have, I'm saying real quick because I want to make sure I don't forget, we have a happy birthday to...
No, we don't.
No, we don't. Just kidding.
Nobody had a birthday.
No birthdays.
Ha, take that, kids.
All right, finish and reveal. Tornadoes have been recorded in every U.S. state. Math Dad.
Did I spell tornadoes wrong?
That is true.
Yeah.
Good job. You did it. I thought for a second that you had marked the wrong one.
Okay, and we're supposed to select the true one. But okay,
yes.
I did misspell tornadoes. Okay, whoops.
All right. Real fast. Let's go through the false ones. Can you always see a tornado before it arrives? No, especially at nighttime. If there's a tornado at night, can't see it. But you can always hear a tornado. They tend to be very loud. And then low wind shear that's false. You need high wind shear to get tornadoes to form. And then can tornadoes cross water? Absolutely. They can. Once a tornado forms, really, it can cross just about anything.
Hard to stop it.
Yes.
Tornado.
So nice job. All right.
Question number 9 here. Why are hurricanes expected to become more frequent in the next 50 years? So options are the temperature of the ocean is increasing, the humidity in the atmosphere is dropping, tornadoes are moving to the ocean, or there is stronger wind shear over the oceans.
So just one of these is correct. It is true. We are expecting to see an increase in the number of hurricanes in the next decade or so. And there is something that's going to happen that's going to cause that increase. Which one is it?
Olivia's stuffed animal is turning 7 today. So that's
happy birthday, Olivia's stuffed animal.
There's the birthday. Man, I'm surprised. I thought this one was going to stump them. But...
No, I think they've got this one. We're going to go ahead and finish and reveal. The answer is temperature of the ocean increasing. That is correct. And I was curious to see which ones would come in next. You need strong wind shear for tornadoes, but actually for hurricanes, lower wind shear is more favorable to hurricanes forming. They're very different.
Was that because that allowed the humidity
it allows for basically that huge storm system to build. Because while a tornado you can kind of think of as coming from one giant cloud, a hurricane is, by scale, is just so much larger.
Right. All right.
Next one.
Maybe.
Uh-oh. Did you almost skip an answer? Skip a question?
I think I'm okay. All right.
Oh. Oh, no. Did we skip one?
Is it for... No. All right. In which climate are you most likely to find a marmoset? A continental climate, a desert climate, a tropical rainforest, or a tropical savanna? Got a vote there that we should move to Minnesota.
Boop, boop.
Insanely beatable math, Dad. Ooh.
Now you have a marmoset drawn by Science Mom Liza on your shirt there.
Ta-da!
And it's kind of an inside joke here for our class. So if someone's watching this for the first time and they're like, why would they need to know where marmosets live? Well, marmosets are pretty cool.
Kind of our mascot here.
Yes.
Well, science puppy, notwithstanding.
Tropical rainforest is correct.
That's
Marmosets are native to tropical rainforests in South America and Central America. And are we sure we didn't skip a question method?
Yes.
Okay. We had item pool kind of like...
I hit the button twice and I couldn't tell if it had responded. It's struggling to load.
You can do it, item pool. You can do it. There we go.
All right. Question number 11. Dew is most likely to form when snow melts abruptly, or when it rains at night, or when humid air meets cold ground, or when air is colder than the ground.
One of these is correct, and the rest are not answers to why dew forms.
Mm-hmm.
And hopefully you remember this from when we talked about weather and relative humidity and things like that. Which one of these will result in dew forming on the ground?
Do 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 do. Do, 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 do.
And we have a clear favorite here. I'm going to go ahead and finish and reveal. And they said when humid air meets cold ground, that is absolutely correct. For dew to form, you need to have conditions where the ground is colder than the air above, and the air has to be really humid. Just like if you are somewhere where it's humid and you take out a glass of water and you have ice cubes in the water, you'll get condensation on the outside of the glass. Same thing. So if the ground is warmer than the air, you can't get dew.
They must have been paying attention, Science Mom.
They were.
All right. Water vapor changing into a liquid is called what? Is it evaporation, condensation, precipitation, sublimation, deposition? What is it?
What do you think, Science Puppy? Science Puppy is kind of asleep on our laps, but I want to hold him up so you can see the adorable, sleepy little puppy.
So I didn't expect to trick the whole group here, but I think I can stump some people on this one.
I don't think so, Math Dad.
Well, clearly some people are giving the wrong answer. I think so, but...
I don't think you're stumping very many people. Maybe they're doing it just to try and boost your confidence.
Sympathy, wrong answer?
Yeah.
You keep telling yourselves that, guys.
All right, let's finish and reveal.
And condensation.
Yes. If you go from from gas to a liquid, that is condensation. The opposite is evaporation.
Say that the water condenses. Okay, this is a multi-select problem. Which layers are within 5 miles of our house, or 8 kilometers of our house? So we got lots of options here. So you might even have to scroll down. You're going to have troposphere, stratosphere, mesosphere, thermosphere, exosphere, crust, mantle, and core.
So we have all the layers of the atmosphere, all the layers of the Earth, and you've got to select the ones that are within 5 miles or 8 kilometers of our house. And just as a quick little hint, we do live on a continental plate, obviously. We don't live on an oceanic plate.
Science, Mom.
Sorry.
All right. Whatever happens, I think we can count this as a victory for me because she gave a hint.
It was a very, very small hint.
No, it's a conspiracy.
And make sure that you do not just go and select all the answers because that will, that will not help. That will not help. Nope.
Uh-huh.
We do have 2 clear winners. Let's go ahead and finish and reveal.
Okay, we've got troposphere and the crust.
Yes.
That is entirely correct.
So if we dug a hole 8 kilometers deep, would we be able to hit the mantle?
No, we need to go deeper to get
way
the mantle.
Way deeper. And it all depends on where on the crust you are. But if most continental places, especially if you live at a little higher elevation like we do, 2,000 feet above sea level or so, you would need to dig for 40 plus kilometers before you'd have any chance of hitting the mantle. It's way down there.
And in the atmosphere, if you go up 5 miles, so you're getting up to about the death zone, but you're not into the stratosphere yet.
Nope.
So the top of Mount Everest is higher than 5 miles above sea level.
And it's not in the stratosphere. It's still in the troposphere.
Still in the troposphere.
So good job, unbeatable science kids.
Nicely done. All right, the time of day when the relative humidity will be highest is when the temperature is the highest or when the temperature is the lowest.
This is my second favorite tricky question after the Tyrannosaurus Rex one. And I bet everyone's going to remember that there's less time that separates us between... No, I'm talking about...
I thought you were going to give a hint.
No. So there's less time that separates us from Tyrannosaurus Rex than separates Tyrannosaurus Rex from Stegosaurus. That's kind of amazing. And that just puts into perspective how long the geological eras are. When we talk about Jurassic versus Triassic versus Cretaceous, there's a huge amount of time that separates those periods. And this one is my second favorite question after that one. You gotta think about it. So relative humidity, the amount of water that the air can hold, is that going to be highest when the temperature's hot, middle of the day, or when the temperature's low, like at night?
I think they're going to miss this one. They did miss it. Okay.
To be fair, I know college students that missed this one as well.
Okay, I missed
let's talk about it real
yesterday.
fast. Oh yes, and Math Dad missed it too. So Math Dad, I think that counts as a tie because
no.
I read him the question. He was typing it in, and then he said, "Wait a second, which one's the right answer?" And I said, "Well, what do you think?" And he confused himself and got it wrong.
No. Okay, so the warm air can hold more water, but what that really means is that the amount of water in the air is at a lower proportion of the total possible amount when the temperatures are warmer.
And here's a way to think about it that I like. So if you have a certain amount of water and then you make the air super, super cold, what's going to happen? You're going to get condensation. And you see that happen when you have a glass of really cold ice. So if you live somewhere humid and in the summertime when it's pretty warm, if you take a glass of ice and you put it on the countertop, you're going to get little drops of condensation all the way around it. And where did that water come from? It didn't come from inside the cup. It came from the air because the air cooled. So relative humidity is highest at night when it's cooler. That's why you get dew in the morning. And in the middle of the day, that's when the relative humidity will be the lowest because it gets hot.
Nice.
So I love Cat's Meow says, "No point, Math Dad. If you got it wrong when you were writing the question, then you can't claim victory because it tricked you too." Now we have a fun question.
It's an important one. I'm kind of curious what people are going to say. Which would you rather have, an elephant-sized cat or a cat-sized elephant?
Now, are we going to assume that both of these would be like well-trained animals?
I think that's fair, yeah.
Okay. So we're going to assume that both of these would be pretty well-trained animals that, would get along with you.
At least as well-trained as a house cat gets, or at least...
All depends on the house cat.
Well, I know. So you don't assume it'll...
Okay. And don't assume
it'll do your bidding. Like, go to the store for me, giant cat.
All right. So we're not assuming anything supernatural, but we're assuming friendliness. So would you rather have an elephant-sized cat or a cat-sized elephant?
All right. The votes are in. And B got the most.
People said
a cat-sized elephant.
I have to say, so a cat-sized elephant, I think, would be probably one of the most adorable things ever to walk the planet. So I found that option very appealing. But an elephant-sized cat, oh my goodness, can you imagine, like, can saddle up and ride around together? Like, that would be...
And it sits on your house, and then the damage it does, even though it's nice. Yeah, I was going to go with the cat-sized elephant, just because it was cute and it wasn't going to break my house.
That's true. I guess if you had an elephant-sized cat and it decided that it wanted to scratch something, it could be like, well, there goes the garage.
Take that, tree.
Both, but to be fair, both would be awesome.
Yep.
All right, next question. Ooh, and we kind of gave away the answer to this one earlier when we were talking.
Whoops.
But let's see if you remember. Top of Mount Everest is in the which layer?
I forgot to reorder the questions.
Oh, were you going to move this one earlier?
Yeah. All right. Is it in the troposphere, stratosphere, mesosphere, thermosphere, or exosphere?
Which one? And we will go ahead and finish and reveal. Troposphere is correct. You are in the death zone on the top of Mount Everest. There is not quite enough oxygen to breathe, but that is still in the troposphere. You haven't yet hit that layer where the air starts to get warmer and you get up into the ozone layer around our planet. So really, if you're thinking about the atmosphere and how big it is, there's only one layer that we can breathe in, and it's like the bottom half of the bottom layer.
Yep.
Next question.
If you needed to measure wind speed, which instrument would you use? A thermometer, a hygrometer, an anemometer, or a barometer?
Which one would you use for wind speed? And I'm really curious, just kind of ask yourself, do you know what each of those are used for? Can you read each name and then say, what is it used for? What do you use a thermometer for? That one's easy. I think you probably all know that. What do you use a hygrometer for? An anemometer, and what's a barometer?
I use them to stump very beatable science kids. That's what I use them for.
They are not so beatable, Math Dad. Our score is that, there's 2 that you managed to stump them with just a tiny bit, and then all the rest, they've squashed you. Finish and reveal. Anemometer is correct.
Yeah. Anemometer.
Yep. And the barometer, that's what we use to measure air pressure. The hygrometer measures humidity. Nicely done.
I thought it would be like hydrometer, not grometer. But yeah. All right. In an ecosystem, omnivores are primary producers, primary consumers, secondary producers, or secondary consumers.
Ooh, which of those best describes omnivores?
They probably don't even know what omnivores are.
Give us an example of an omnivore in the chat, you guys. Let's prove to Math Dad that you know what omnivores are.
They're just probably pretty good at guessing.
Nope.
I think that accounts for most of their points.
All right.
You probably call it a draw at this point.
Nope. I'm waiting for an example of an omnivore in the chat. Kai says us, and a lot of people are omnivores.
Oh. Yep. Humans eat.
A lion. I'd say lion's more of a carnivore, although
carnivore.
Maybe it sometimes eats grass or things.
A bear.
A bear. That's what I was thinking of. So
bears eat meat.
Yep. Shelly.
Plants.
Yep. Shelly said bear, and a bear is one of. Oh, now we've got tons of them coming through. Chickens.
Pigs.
Yep. And when people say that chickens are vegetarians, really chickens are pretty. They eat a lot of insects. If there's something outside and it's moving and it's small, they will gobble it right up.
All right. So the answer is secondary consumers.
That is right. A primary consumer is an herbivore, something that is strictly eats plants. If it eats insects and other meat as well, like a bear, then it is an omnivore. Good job, you guys.
Ooh, got a numerical problem here.
Jupiter is 7 times as far from the sun as Venus. How many times more intense is the sun's light on Venus than on Jupiter? So we told you guys we were leveling up with some trickier questions. This is another one of those super challenge questions. So real quick, just direction for you. If you're watching the replay and you want to pause and figure it out, go to when we talked about the inverse square law.
No hints, Science Mom.
It's just a really
hints.
tiny hint.
No, trying to figure out how much more intense the light would be from the sun on Venus versus Jupiter. We know it's going to be brighter because we're closer, but how much brighter?
Really entertained by the chat here. I saw someone say, "Oh, help save me! I have no idea." Think about the inverse square law. That will help. And if you can like flip back in the notes real quick to try and take a look, but I think as soon as we get
don't give them a false hope, Science Mom.
As soon as we get to about 42 answers or so, then we'll go ahead and finish and reveal.
It's okay to despair, guys.
I bet I know what the second answer is going to be. I'm hoping for that first one to be correct.
All right.
Let's go ahead and finish and reveal.
Oh no, I've lost the mouse. There we go. And the answer is 49.
Yes. So how did they do that? And then the second answer is marmoset. I love it. How did they get 49?
7 times 7.
That is right.
You square that number. So 7 times 7 is 49. And that inverse square law says that, if you go 3 times as far away, you're only going to get 1/9 of the light.
And if you're 5 times closer, then the light's going to be
25 times more intense.
5 times 5. Yep. Nicely done. Good. Kudos to everyone who remembered that or ran and looked it up. Good job.
Okay. For our next question, thinking back to our day when we talked about waves and making models based off of waves, we used several terms such as wavelength and amplitude, crest and trough. But in this question here, where we were modeling the hours of daylight, I want to know, what is the amplitude of this curve?
Ooh, and it's going to be blank number of hours.
Yep, some number of hours.
Put in a number.
Yeah, it's a lot harder for them when I don't give it multiple choice. That's the only reason they get them right. So I think it's because the multiple choice problems, they can guess them right.
Debbie wants to know, how did 11 people write? And then because it's set to be numeric, if you type in marmoset, it alphabetizes
it thinks that it's a mathematical expression, so it tries to treat them like variables, and then it changes the order so that even if somebody put the letters in a different order, in math it doesn't matter when you multiply numbers.
Two variables, yeah. So people were not typing in an anagram of marmoset; they were typing in marmoset, and then it switched them around.
But I was confused when I saw it too the first time.
Yep.
Okay. Ooh,
boy, this one's close.
Super close. I don't think you're gonna get it, Science Mom.
Oh man, I'm on the edge of my seat. 1616, it's tied. 1816, and the one that was second jumped up.
Oh,
come on, unbeatable science kids, you've got this. All right.
I love it when it's close.
We're gonna finish and reveal.
And it said 12. No, wow. So it looks like this one stumped everybody big time. I think you guys can see the graph. How's that?
You know what? Yeah, the graph might be small enough. I wonder if they were not able to read those numbers.
You definitely have to be able to see the numbers for that to make sense. But
let's talk about this one real quick. And Math Dad, because I don't know if they could see the numbers well, looking at how small that was, I think we're going to call this one a wash.
Are you kidding? Hardly anyone got it right. All right. So what was the answer on this? The answer was 2. So the amplitude, whenever you have a wave, the amplitude is half of the total distance from the top to the bottom, from the crest to the trough, or it's the distance from the baseline to the top. That's what we call the amplitude of our curve.
But you had 14 hours on top and 10 hours on bottom.
So that was a total difference of 4 hours to go from bottom to top. So the amplitude was half of that 4 hours, just 2 hours.
That was a very tricky one, Matt. I don't think I would have gotten that one right.
Apparently not. All right. So I won, right? I think I had slightly more points than they did. Was that right?
No, they have way more points than you. So if we count this one, you have 3, and I think they have 17.
What? You sure it wasn't more like I had 11 and they had 9?
Yeah, I'm sure. I'm sure.
I wasn't keeping an exact count. I just assumed.
No, let's talk real quick. Math Dad loves competition. He thinks it's so fun to do the little trash talk and you're going down and everything. But the most important thing is that you're learning and that you enjoy the learning process. So that's why we make it a little bit of a game. But to anyone who is like, getting really into this and then is feeling like, no, the score was 3-17. 3-17. I mean, that's kind of awesome, you guys, especially since we snuck in some pretty high level questions.
Not bad, not bad.
One question that would have stumped me and one question that did stump Math Dad. All right.
So what did you promise them if they won?
So if they won, they got to see all the dances plus a new one.
All right, let's deliver.
All right.
Deliver on this promise.
Here we go. You guys ready? Good job, unbeatable science kids. We're going to pull up.
Here, Kaladin, come watch with us.
We're going to go in order. The chicken worm dance will be number 1.
All right, try a worm.
That one is my favorite, I think. It makes me crack up every single time. And next we have the Russian squat. That one also makes me laugh every time. And Kaladin, each time the music comes on, is like, what is going on? Now... That was Math Dad's attempt to orange justice with different music than what you typically see in that little video game. And next we have his attempt at ballet. And yes, I know that wasn't really ballet. That was waltzing, flossing, and turning around with your finger on your head.
Isn't that what ballerinas do?
No.
No?
No, that's not. And then we have a victory dance. And last but not least, we have a silly robot dance. And I will say, if you've ever tried to dance like a robot, it's a little harder than it looks. Science mom Jamie says, wow, they just keep getting worse. I think that makes them even more fun, right?
By worse, she means better, I'm sure.
Thank you so much for participating with us today. And if you're watching the replay, I hope you enjoyed going through and just testing your knowledge to see how much you have learned going through this course. Our planet is so incredible, and yesterday was Earth Day. I hope you guys will think about what you can do with what you've learned about our atmosphere and the geology and the hydrosphere of our planet. What can you do to save water, use less water? What can you do to protect the air that we breathe and keep it clean? Because that's a super important thing that we all need to be working towards.
So are we going to play the atmosphere song to send them on their way?
Yes, we will do that. We'll play the atmosphere song and then we will be done. And we'll see you next week. Let me just pull it up real fast. Here we go. Sing along if you'd like, and then we will see you on Monday.
We live in the troposphere, bottom of the atmosphere. All Earth's weather happens here in the troposphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. Warmer than the air below, ozone layer had a hole. Airplane contrails white like snow in the stratosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. Never see a shooting star, the mesosphere is where they are. Coldest layer on Earth by far, in the mesosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. Molecules extremely hot, radiation ions brought, space station for astronauts in the thermosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. The exosphere is way out there, near the space it's such thin air. Satellites are everywhere in the exosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere.